Welcome back. Today we are going to work on making this sling mechanic. I got this from a game called Windbound, and this right here is my rendition of it. There's two asset packs that we will be using for this. One is the starter assets third-person character controller, and then the other is this prehistoric low poly animals asset pack that gave us this mammoth and this whole terrain and stuff. I will link both of these in the description. I am very pleased with both of these packs. The way this mechanic works is you have a wind up to it where you have to hold down your mouse button in order to get more accurate with your slingshot, and then when you release the button, a stone is thrown. Some things that you will want to set up ahead of time. You need a character that can move around, as well as a method of aiming. So in my case, I have two Cinemachine cameras and my right mouse button toggles between them. And then I just have the third-person character starter asset pack for my character. Can move, walk, jump, do all that. That's all set up for me. This is using Unity's new input system. You can do all of this with the old input system, but this is how I chose to do it for this project. There's a couple things we needed to set up. First, you need an environment. In my case, I went ahead with this level right here. This is the sample scene from the low poly prehistoric animals kit. Do note that I added invisible box colliders all around the level to give my sling, the aiming guides, something to raycast to. In addition, we have to set up our stone prefab. So I went into Blender and I modeled a stone. Pretty simple, just started with a sphere and then just sliced off parts of it with the bisect tool. Then I went into Affinity and created the reticle, which is this graphic right here. This was created by setting 4 of these circles in succession. I increased the distance they are from each other going down, and then making sure that my canvas size was set so that this first circle, the center of that circle is at the center of the canvas. This means that when I aim, this point will be at the center of my cursor. When you are in the optimal range for the sling, your shot is going to go straight to your cursor. The way the rangefinder works is if I'm aiming further out, because of the arc of the stone, I'm going to want to aim higher, which is why we have the dots in succession. As for setup inside of Unity, I've got my character set up like this. My character is going to have 2 game objects, empty game objects, right point and left point. These are going to be rotated 45 degrees and negative 45 degrees on the y-axis. These are the starting points for my sling. So when it is aimed the least, like I haven't touched the button at all, that's where they start off at. Each of these will have a child empty game object called left launch or right launch. These are tilted on the x-axis. I found that -4 works well for me. This is going to be the actual point that spawns our stone, and it's tilted up so that we have that arch in our slingshot. I have 2 debug objects right here and right here. These will just indicate what my reticles are aiming at, my left one and my right one. And then I have another debug transform, which is just this gray ball, which is to represent what I am looking directly at. Let's jump right into the code. We're gonna go over our projectile script first. This script would still work for an arrow. So we have a rigid body, and we have a bool that tracks if we've hit something, and then we have any particle effects or whatever you want to hook up. And start, for a safety check, I'm gonna make sure is kinematic is set to false. For an arrow, once you hit something, you want it to stick in it. The way you would allow something to stick and not move when it has a rigid body is by enabling is kinematic. In my update, we rotate our stone. So if we haven't hit anything, we're going to rotate our stone by this angle. The angle is calculated using the velocity in the y and the velocity in the x, getting the tangent of those and then converting those to degrees. Then we just simply rotate ourselves along our forward axis by our angle. What this means is as we start arcing up, the rock is going to rotate to face forward, essentially. And then as we start going down, it's going to keep rotating to facing forward. So it has that nice arch to it. Then if we collide with anything, we're going to call disable stone. We enable has hit, and then we spawn our particle effect, and then we set our velocity to 0. This is going to make my stone just kind of impact and then just fall to the ground. You can see here, if I shoot a stone at this mammoth, it impacted there and then just fell to the ground. This would be where you would add your RB is kinematic equals true if you wanted to disable its movement entirely and not have it fall to the ground. Next is our sling mechanic script. So this script is going to have a lot of stuff in it. Some of it will look a little bit different for you because you might be using the old input system, and I'll cover that once we reach it. So we have several batches of transforms and rect transforms. This first group right here is our left and right reticle. These are the UI elements. And then we have a vector 3 for their original spots. We do the same thing for the transforms in world space. So this is my left point and my right point. These are the parent transform, and then I save their rotations. Then we have the actual spawn points. So these are the points that our projectiles are fired from. We have a launch force variable. This is how much force the sling has leaving the bow. So what's the initial force acting on our rock? We have our rock saved, of course. Then we have the starter assets inputs. That's if you are using the starter assets pack as discussed before. You would not have this if you have some other character controller set up. Then we have our bool, which tracks if we have fire or not. Our aim rate, which is how quickly the reticles shrink towards the center of the screen. So if I increase this, it'll take less time for them to fully aim. I have it fairly slow right now. We have a reference to our camera, and then we have references to our debug objects. So the left rangefinder is, I believe, the red one, and the right rangefinder is the green one. It might be in the other way around, but it doesn't really matter. Again, this is for our input system. We get all of our references to our UI elements. So we're going to find an object with the tag left reticle or right reticle and access our transform component. Then we're going to save all of our original spots. So we're saving our original rotations and our original locations of our UI elements. And then here we just cache our camera using camera.main. This is just an efficiency thing. Then in our update, we're going to ask if starter input assets.shoot. What this just means in new input system terms is, did I press the left mouse button? The old way of saying it would be get mouse button down 0. So if we are pressing the left mouse button, we're going to start drawing our sling. So we're going to come down to this function. The first thing we do is we lerp our position of our left and right reticles towards the center of the screen, leaving the Y height alone. So it doesn't change the Y height, but we will be lerping closer to the center of the screen. All lerp means is we are taking option A and option B. So option A is where it is currently, and option B is where we want to go. And it is moving us there at this rate, which is our aim rate times time.delta time to make it frame rate independent. Each time, each frame this ticks, the reticle is going to be moving just a little bit closer to the center. So it effectively creates an animation. We do this for both the right and left ones. And then we draw some rays. So we draw a ray from our camera to where our UI element is, and then save that information in a raycast hit variable. We do that right here in this if statement. Say we raycast, feeding it our ray right here, and then we save it in the hit, and then we move our aiming point to that position. So this is our debug, the red or green spheres. If you don't want a visual indicator, you would just remove the sphere component of those objects and just have them be empty game objects. We set their location to hit points location. Do that for the right one as well. And then we rotate our fire points. And the way we do that, now that we know what we have hit when we're looking at something, all we have to do is rotate them to look at that thing using transform.lookat or quaternion.lookat, which is what we do right here. Then we set has fired equal to false. Then we check to say if we release the left mouse button. The equivalent of this in the old input system would be on mouse button up 0. So if we have not fired this frame and we release our mouse button, we are going to fire. The way we fire is first we need to get our transforms fire point. This is a new variable that we're making. We're basically choosing which side we're shooting from because we want it to be random. So this is very simple. We just choose a random number between 0 and 2. And then if it's 1, we say we're firing from the left side, otherwise we're firing from the right side. Then we spawn our rock at that fire point's location, the one that we randomly chose. We're going to access the velocity on the rigid body of that rock, and then set it to its forward vector times our launch force. So this is going to start our rock moving. Then we reset all of our UI and fire points to their original spots and sets has fired equal to false. I'm gonna zoom in and you can see right now without clicking anything in the center there, you see my debug showing what we are looking at. So this is a raycast from the camera just straight ahead. Then if I start aiming, you'll see the green and red spheres appear, and these indicate our raycast from our camera to the reticle's positions. And if I just click without aiming at all, you'll see it'll randomly choose if it fires on the left side or the right side. If I hold it down to aim, it'll always go to the same point because they're at the same point. Basically how this system works. And you can see with the rangefinder, sometimes I'll have to aim higher than my intended target, like the top of that tree, in order for it to actually hit. We can see inside of this side, inside of our editor, I'm going to go ahead and select our right point. Pay attention to the transform side over here. So if I start aiming, see how its rotation numbers change? This is because they are rotating as you are aiming. I hope you guys found this video interesting. Please hit the like and subscribe buttons, comment below if you have any questions, and I hope to see you in the next one. This whole process was a ton of fun.